Hey, what's up, guys? How are you? And in today's video, I'm going to demonstrate my Google AI intensive capstone project, which I named as SuperFarmer. And this is an AI farmer which can predict, manage, and resolve issue and plan your entire crop plan. Basically, we have created an agent for the farmers because farmer needs a guidance based on their they have land, they have all the other resources, but they don't know how to proceed in it, how when to do irrigation, when to do sowing, and when to do fertilization. So we have created one agent that can do all of this by taking just some user inputs. So we have written this on Kaggle itself, and all the other details related to this project can be found here. We have wrote all the details in it. So we have created almost seven agent. First is the intake agent, which can take the inputs from the farmer and can serialize it into a good format that can be recognized by the agent. Second one is the crop recommendation agent that will recommend you crops, or we can say specifically say seeds, based on the soil suitability, season, and all other essential parameters. Then the other one is a crop planner agent, which can generate a full agricultural plan based on the inputs that has been given by the farmer. Then there is a one more disease diagnosis agent which can diagnose the disease, because as you know, in the farm, disease can be happen on the plant. So by this agent, like with the using, we have created these agents so the user, or I can say the farmer, can demonstrate their disease of the plant, and then it will give you a best we can say solution to prevent the and the cure the disease. Then there is a one dynamic replanner agent, and this is the best one. By this, suppose you have written that today is a very today heat wave is coming, or today is very raining, or I don't have a water capacity that much. So it can dynamically replan your agent based on the input that you are given, and it can also replan the crop plan using the weather changes or water shortages or resource availability, any of the farmer concerns it can take, and then it can replan the entire crop plan you with the using of crop planner agent, and it will going to modify all the others input that has been given by the farmer in the initial stages. Then the last one is the report agent that can provide you a complete summary uh, of the crop plan, and all of this were coordinated by this orchestrated flow. And this is a route agent that will intelligently routes all the user queries to the different agents. So here you can see all the graph how it can be, it is mapping all the user queries. And I have also written some example flow, but I will show directly into the code how it is being like how it is being how it can be used, and how it is being producing the outputs. Also, we have used data persistence using the local SQLite session service, and we have used DB session storage as the DB session service, which has been demonstrated in the Google AI 5 days intensive course. It can store all the essential parameters that can be helpful for the farmer. So whether if the user want to restart the server, or whether they want to continue the conversation after a long time, the agent automatically recognize all the data persistence, and it has a lot of benefits as I mentioned. So let's see, directly jump into the code and let's see how it is working. So as you can see, we have defined our complete code in the Kaggle notebook itself. You can see the link down below in the description. So we have first imported the Google Gemini API key. Then we have imported all the essential ADK components. Then we have defined some helper function that will be reused throughout the notebook. Okay, so that is by default. Then we have also written one retry configure so that it can just not fail with the basic errors. It will retry it if some basic error comes. Then we have defined some basic constants. Then we have defined the data models. We have defined the nutrition info. We have defined the field profile. All this can be filled by the agent itself. Whenever you will give the input to the agent will directly directly shape your layman language, or you can say English language, input into this class based data models. Okay, so we have all the data models here. We have defined in this cell number 6. Then in the cell number 7 to around 14, we have defined all our agents. We have given it the description. We have tweaked the fine tune the model as a little bit so that it can predict good responses. Then we have defined the instructions. We have defined the detailed instructions so the agent doesn't, misunderstood the instruction and give you unusual outputs. So we have detailed define all the instructions. Then we have also defined the output schema and output key. Just output key schema for long term, or we can say to shape our data, and output key is some basically for the session storage so that it can refer it better, the agent itself refer it better. Then we have also defined the recommender agent as same. Then our planner agent. Then our diagnosis agent, and after that the replanner, and at last but not the least report agent. Okay, and after that we have defined our DB URL. Okay, and our session service. Okay, we have defined this both here in this cell number 13. And after that we have defined our root coordinator, or we can say the orchestrator agent. And this agent, as you can see, we have a used agent here, and in all our other agents, we can say the sub agents, we have used the LLM agent from our Google ADK. Then after that, we have defined our orchestra agent. We have given it a brief instruction. We have a detailed instruction. I should say detailed instruction about the rules, about the, as I am creating this from the India, so we have defined it on the Indian specific intent recognition, and also we have defined the output format also. Okay, and then we have defined the tools, all the sub agents, intake, recommender, planner, diagnosis, planner, and report. After that, we have defined our app, and for the long running session resumability, we have used reusability config. Okay, in this we have defined some critical parameters so that it can refer to the full history uh, of the user chat. After that, we have defined our agent, and as you can see, the kernel reusability is experimental, so that is okay for now. We have defined our runner. We have defined the app in it, which we have just created above it, and the session service, which we have defined in the above cells. After that, we have defined the user ID. So if you want to, suppose that if you are chatting with the agent for a long time, and if you want to, do a fresh start, so you can just change this db session id to any other string, and it will give you a fresh start. And see, when I am saying to the jet hi, it is saying namaste, how can I help you, please share your land. It is asking me the details that it requires to communicate further. So whatever detail will be missing here, suppose that you have given all the details, and if you will say hi, then it won't ask you the details and again and again. Only when the details is missing from the data model, it is asking us. Okay, so then I have given it the input. I have 5 acres of black soil in land. In those I have defined the soil type. Okay, I have defined the size of the land, I have defined the location, I have defined the season, all the things in one line. So see this, I have defined this, and then see this here, you are detailed 5 acres in indoor with black soil for rabi season, how can I help you further. Okay, so he has identified my details. Okay, then I'm saying that design my crop plan. So as you can see, when I'm say design my crop plan, it is asking me what crop would you like to, would you like to would you like to put in your crop, because I haven't mentioned which type of soil, which type of crop I want to grow. So when I will give it the complete input, it is generating, it is giving me the complete field preparation plan, and it is also giving me the idea of sowing, fertilizer schedule, irrigation schedule, weeding, and pest precautions. Sorry for the mispronunciation. Weeding. Okay, and then pest precautions. So it is giving me estimate cost as well, and expected yield as well. So as you can see, our model is working perfectly. Orchestration model is perfectly, plotting the query to the particular agent tool. Okay, then when I'm saying that again, show me the report, or if you says show me the report, then it is see here it is giving me the season report. The plan is for 5 acres, and all input is all output is here. And whenever I say hi, see this. Now it is not asking me about my details because I have already given it. It's asking me how can I help you further. So then I've asked any new alert for this week. If is there a new alert, please let me know. So it is taking this input and see this. Here it is providing me the report. Wheat will be planted on 5 acres. The field has a black soil this week. Prepare the field, plow the land truthfully and compost for soil health. Water the field weekly, and all the things it is giving me here. And suppose if I will ask it about 5 to 10 weeks later, then it will give me some other kind of alert. So this is our project, and I hope you liked our idea. I hope you would like our idea, and if you want, you can test it by yourself and provide your own input. Make sure you will change this user session ID if you want to do a fresh restart. And whether if you will restart the kernel, it doesn't affect our uh, whole whole sorry, whole chat, because we are using a DB session service here. Okay, so this project is made by me, Dhruv Gaming, or my official name is Dhananjay Arne, and my fellow teammate Sakshi Rathod. So I hope you will like our project, and this is all about Super Farmer. So Super Farmer is not just a AI tool; it is a, if you can say, it is a farmer to the farmers. Okay, thank you so much for seeing the complete video, and I hope you like our project. If you like our project, then please give up a upvote here. Okay, thank you so much.